Using our problem statement, the idea I am pitching is for Nana Kaniba in Mali, where women in the village use multiple stoves for different purposes, and we want to focus our stove for them to boil water using solar power. The problem is that the sun isn't out all 24 hours of the day, so we need to design a way for the stove to also store the heat.
Our mission statement is mostly for the women in the village of Nana Kaniba, who are the target market. It's a solar cooker made out of basic materials. Some benefits include using the sun's energy to cook their food or boil their water rather than using wood as fuel. It's cheap, it's affordable. One of our constraints, though, is that it needs the sunlight in order to cook whatever they're cooking, food. So this concept design is called the Fun Panel. It could be homemade and built in 1 to 2 hours. It's basic materials made out of cardboard and aluminum or tinfoil. The dimensions are about 20 inches. Here's our objective tree for that. It's just the Fun Panel. 3 basic items are safety, the requirement for it, and its efficiency.
For our objectives of the stove, we wanted it to be safe, meet the requirements of the user, and meet the preferences of the user. So for safety, we didn't want to use any gas and no burning of wood, and we didn't want to use chemicals. For the requirements, we wanted to be able to boil half a liter of water and maintain our temperature. And then for the preferences, we just wanted it to be easy to use and maintain, and we wanted to be low cost and portable for the user. One of the concepts that we looked at for the stove was the solar cooker Go Sun Sport. Some of the positives for this stove are that it works like a microwave or a toaster oven. It's fairly compact, quick, and it doesn't take up a lot of room. Some of the negatives for the stove would be that since it's not very large, it wouldn't be able to cook a large meal for a family of 4 and at once. You would have to use it multiple times. And also, regular pots and pans could not be used in this type of cooker.
Another type of solar cooker that we found was a box solar cooker, which essentially just reflected light using a panel into a box which trapped heat, like an oven. It reflects the light from that panel into the box through a clear, usually plastic or glass surface, which converts the UV rays from the sun into infrared, which can escape that box, thus trapping the heat inside and heating the food and water. Using the box solar cooker, one of the benefits could be that it can be made out of cheap and affordable materials such as wood, plastic, glass, and metal. It can reach temperatures of 150 degrees Celsius, which you would only need 100 degrees to boil water, and it can retain that temperature for a long time. And because it's a box, it is more resistant to tipping over. Some of the cons include that because it is a solar cooker, it is dependent on the sun, and it can't carry too much water or food, especially if you need to carry it or move it, it will tip inside.
In this design, there is a reflecting dish that reflects the sun's beams to a single focal point to get the maximum amount of heat to the pot. And to store the heat, it has a second reflecting dish as shown. The pot is surrounded by a water loop which spirals into the reflector to the region of the sand. The water tube shown in the picture in red gets heated and turns into steam, which heats the sand. When the sun's out, the lower lid of the pot is removed, so more heat is going to heat up the sand. To insulate the heat the sand is capturing, there are coconut husks trapping all that heat in as an insulator.